This is exam number 1. This is problem number 3. So here's the problem. A committee consists of 8 women and 11 men. 3 members are chosen as officers. So the 3 members are chosen from the entire committee, right? So there's 8 women, 11 men. So there's a total of 19 people on the committee. What is the probability that all 3 officers are women? That's the problem. Okay, now I'm going to do this problem the way it's stated, but I want to point out that the technique that I'm going to be using would be exactly the same even if we change the problem around a little bit. So for example, let's say you said, 5 members are chosen as officers. What is the probability that 3 of them are women and 2 of them are men? It'd be the same basic technique that I'm going to demonstrate here coming up. So let's take a look. Give me one sec. Okay, so my typical format, what am I given? The information that I'm given here is that the committee has 8 women and 11 men. 3 members are chosen as officers. Find the probability that all 3 chosen are women. Let's have a little discussion here. We note that the problem only says chosen as officers. It does not mention a position or anything that would imply that the order counts. Because the reason this is important is because if the order counts, or if there's some sort of an arrangement, then we have to talk about permutations. If the order doesn't count, if there's no sort of discussion, or they don't imply that there's an arrangement of some sort, well, then we use combinations. Okay, so that's the very first thing you have to look at. Okay, so continuing the discussion. This problem is an example of the formula and definition, and I'm giving this to you, and I'm hoping you're looking in your book. It's on page 189, section 4-1, that explains this concept of what this author is calling classical probability. The probability of any particular event is the number of outcomes in that event over the total number of outcomes in the sample space. So it's like the number of successes over the number of possibilities is maybe an easier way of saying it. Okay, we're also going to use section 4-3, page 213, and this is the so-called multiplication rule number 1. And what that says is that when there are 2 events that are independent, the probability of both occurring is, you just multiply them together. So and now this rule applies if the events are independent. Well, are these events independent? Okay, what has to happen in order to get the outcome that you're looking for? In order to get all 3 chosen to be women, what has to happen is you have to choose 3 women out of the 8 women that are on the committee, and you also have to choose 0 men out of the 11 men. Well, are those independent events? I would say they are. I mean, it's not like selecting playing cards and you don't put the card back in. Nothing changes, right? They're independent events. How do we figure this one out? How do we figure this one out? It's the same. This is the basic definition in classical probability. Then the probability of getting 3 women, choosing 3 women out of the 8 that are on the committee, well, that's the number of ways that you can choose the 3 women over the number that's in the sample space. And then same thing here. The way we can choose 0 men out of the 11 men is, well, how many ways can you pick 11? How many ways can you pick 0 men over the number that's in the sample space? Now, is this denominator here? It's the same, right? The number in the sample space, that's the denominator for both of those. Do you see why this is the denominator? It's 19 people, 19 human beings on that committee, and you're choosing 3 of them. So it's 19 choose 3. That's the sample space. That's the number of things that can happen in the sample space. So there's 19 choose 3 ways of choosing 3 people out of the committee. total, men and women. Okay, so that's the total sample space. Uh, my All right, so now how many ways are there? There's 969. How do I know that? Well, I work that out on a separate piece of paper. That's my scratch paper that I have on the next page. So the important thing is, do you see this? Do you see this? Do you see why the probability of choosing 3 women out of the 8 women is 8? Choose 3. 8 is a total number of women. We're choosing 3 of them. That's in the numerator, and the denominator is um, the total number of outcomes in the sample space. So now you see why these definitions are so important. Okay. All right, and I'll show you my worksheet here in just a minute. It was easier to do it on a separate piece of paper. So, number of ways of choosing 3 women over the number of people in this, or the number of events in the sample space. So that's 8 choose 3 over 19 choose 3. Over here we have the number of ways to choose 0 men. So it's 11 men. I'm choosing 0 of them. And then in the denominator is the same thing. It's a sample space number. Okay, so these are the numbers I get on my next page. So I crank those suckers out, put it on my calculator, and this is what I get. So now the only hard part, not hard part, but the only thing I haven't shown you yet is how do I get these numbers. So that's in my worksheet. So remember the formula, n choose r is n factorial over n subtract r factorial times r factorial. Now I've mentioned this in previous videos, but I'll mention it just one more time here. What's going on here is this n subtract r factorial, that cancels out a bunch of these guys up here in the numerator. So what really happens, a shorthand way of looking at this is n choose r, it's n times n minus 1 times n minus 2 and so forth. You write down r of those factors up here. So if it's 8 choose 3, it's going to be these first 3 guys. So it's 8 times 7 times 6. That's this part right here, taking into account the cancellation. But then I also have this r factorial, so that's my 3 factorial right there. So cranking that out, I get 56. Here's another one. 19 choose 3. So I write down the first 3 factors of the factorial. So it's 19 times 8 times 17. And then here's my 3 factorial. There it is. Okay. So you can pause the video and look at that. And I believe I'm correct. Okay. All right. So that's the end of this problem. I hope that helps you. And we'll move on to the next one.